Hello students. So on our previous classes we were looking at our chapter number 6, okay, of NCERT book of class 7, that is physical and chemical changes. Okay, so we were at the beginning and today we will be looking at what is physical change. Okay, so here in the first slide itself, so this is the definition. Okay, definition of physical change. So what is a physical change? A physical change is a temporary change in which no new substances are formed. It is easily reversible such that the composition of the substance does not change. Okay, so earlier we have seen what is reversible changes. Okay, and we all know that everything around us at one or the other point of time it occurs or it undergoes changes. Okay, so this change can be majorly classified into two types of change. That is, one is physical change and the other one is chemical change. Okay, and we are looking at the first type of change, that is physical change. Okay, so this is the definition. Okay, and what this definition exactly means, we will be understanding it as we proceed through our class. Okay, so to understand what this definition actually is, what we will do, we will go through some examples. Okay, so the first example is melting of ice. Okay, many of you, I think you know about this, and those who didn't know, we will be discussing it here in details. Okay, so melting of ice. Okay, so here what we are doing, we are using a beaker and we are placing some ice cube in it. Okay, and we are heating the beaker with the ice cubes from below. Okay, we are providing it heat. So what will happen, as the temperature increases due to heating, the ice will melt. Okay, and ice will melt into what? Okay, so ice will change, so it will change into what? So we'll see that as we heat, the ice will start to melt into water. Okay, as we keep on heating the ice, at one point of time all of the ice will change into water. Okay, so at the first point of time we can see that a clear change is taking place, that one substance is changing into another substance. Okay, but let us see that is it reversible or not. Okay, so we have seen that physical changes are reversible, so I am considering this as an example. Okay, so if this is an example, this change should be reversible because we know that physical changes are reversible. Okay, so what will happen if we try to reverse it, and how can we reverse this change? We can reverse it by this. So what we are doing, once the ice melted, we got water. Okay, now we are taking that water in this beaker. Okay, now this beaker has the water which we got by melting of ice. Okay, and now what we will do, we will freeze it. Okay, so we will freeze it in the refrigerator. Okay, so once we freeze the once we freeze the water, what we will get, again we will see that this water changes into the ice. Okay, that means first what we got, we got water by heating the ice, and then we got back again ice after freezing the water. So that means once we change the ice into water, we can again change the water into ice. So this process is reversible. Okay, and we can also see that the change that is taking place is temporary. Okay, so whenever we want, we can change back again the water, again we can change the water back into ice. Yes, so we can see that change is temporary. And what you can see, one more thing you can see, that here ice and water both are different form of water. Okay, so ice and water both are made up of what? Hydrogen and oxygen. That is, we know the formula of water is H2O. Okay, so the formula of ice also has what? Ice also has water, but in its solid state. Okay, so ice is the solid form of water and water is the liquid form. Okay, so chemically, or the composition of both water and ice is same, that is H2O. Okay, so during this process we can see that composition of the water, it does not change, it remains same. Okay, so the composition will remain as H2O. Okay, so that we have seen, what we have seen first is that the change is temporary, the change is reversible, and again the composition does not change, only the shape, or what you can say, the state has changed. Okay, okay, then now let us move into the next example. Okay, so this is an example, that is we are using electricity and we are using a electric bulb. Okay, so what we'll do, we will use the electricity to make the bulb glow. Okay, so before the bulb glows, you can look at this bulb. So bulb has a filament. Okay, so here this one, this is the filament of the bulb. Okay, and this filament is the thing that glows when we pass electricity to it, and due to this glowing of this filament we get light from the bulb. Okay, so now what we will do, we will switch on the bulb. Okay, we will switch on the bulb, and what will happen, the bulb will glow. Yes, here you can see the bulb is glowing. Okay, so what you see, that the filament, okay, this filament glows. Okay, and due to which we get light, but the overall shape of the bulb, it remains the same. Yes, only what changes, its appearance change. That means earlier the bulb was not giving us any kind of light, now it is giving us light. And the filament, earlier it was not glowing, here the filament was not glowing, and here the filament is, again glowing due to passing of electricity, and we are getting the light. Okay, but the substances, that is the shape of the bulb or the bulb, it is all the same. Okay, only the appearance is changing. Okay, so now what we will do, we will again try to see that if the change is reversible. So how we can try, we will simply try to switch off the electricity and see what happens to the bulb. Okay, so now what we will do, we will switch the electricity off. Okay, so that the bulb does not get any electricity, and we will see what the change occur. So we see the bulb simply, it stops glowing and it returns to its original position. Okay, so now this bulb, and this bulb, we can see they are similar after switching off. Okay, that means what, we are getting the original bulb before passing the electricity. That means the change is reversible, the change is also temporary, and since only appearance is changing, that is no chemical change or nothing, the composition of the bulb is not at all changing. Okay, only the appearance is changing, so we can say that this is also a physical change. Yes, okay, so from this we can define, okay, so from this we can simply conclude. Okay, so we can see, now we can write down some properties of the physical sense from the example that we have already considered. Okay, so what are the properties? First, we have seen that no new substances are generally formed during the physical change. Yes, so in this example also we have seen that no new substances is formed, only the appearance is changing. Okay, and we all know the change is temporary. As soon as we switch on the electricity, the bulb glows, and as soon as we switch it off, the bulb again stops glowing. Okay, so that means the change that is taking place is temporary and it is not permanent. So since the change is temporary, we can easily reverse it. Okay, so we can get back the original position of the original substitute or original substance that we are using. Okay, so that means the change is reversible. That means we can get back the original substance as it was before the change occurs. Okay, and another one is that only some physical properties like color, smell, taste, state, okay, color of, that is, if we see the bulb before it glows, the color was simply colorless, and when it glows we can see that it is giving us light. So similarly, we can see if we dissolve some salt or sugar in water, So once the salt or sugar it dissolves in the water, we can say that the taste, we can see that the taste of the water it changes. If we dissolve salt, then the taste of the water will be salty. If we dissolve sugar, then the taste of the water will be sweet. Okay, so due to some physical changes like dissolving salt or sugar in water, we can say that the taste of water changes. So here we can see that the physical properties, that is taste, change. Okay, so in case of melting of ice, we can say that the state, okay, state of water is changing from solid to liquid. And again, when we cool it or we can freeze it, then we can see that the change is again converting the liquid water into solid ice. Okay, so only some physical properties changes during physical change. Okay, and now we have already seen, while we issued the when we saw the last two example, that is the composition of the substances remain unchanged. Okay, so in melting of ice, we saw that ice also has water, and the composition of water is H2O, and the liquid water also has water molecules in it, and whose composition is H2O. That is, the composition of the substance remains completely unchanged during any physical change. Okay, so these are the properties. Okay, so these are the properties through by which, or by looking at these properties, we can say that either the change is physical or chemical. If any one of you are asked that uh, are given 2 or 3 changes, and if in exam it is asked them and describe which is physical state, a physical change, which is chemical change. So how you can describe? We can describe by observing these properties. Okay, so if these properties are satisfied by any change, then we can say that the change is completely physical. Okay, and in case of chemical change also, we will be looking what are the properties of chemical changes. Okay, so these 5 properties, you have to remember them, you have to understand them, because these properties are important to classify a change as. So if any change satisfy these following properties, so then that change will be classified as physical change. Okay, so next here we are seeing on some of the other examples of physical change. That is one I have already told, the dissolving sugar or salt in water. Yes, so as soon as you will dissolve sugar or salt in water, you will see that the taste of water changes. Okay, but when you evaporate the water by boiling the water, once the water vaporizes, you will get back the sugar and salt. Okay, so this is a physical change because it is reversible, and as soon as you evaporate the water, you will get back the sugar and salt in its original solid state. Okay, again evaporation of water. Okay, so evaporation of water is a physical change. Okay, so once the water evaporate, if you can condense those water vapors, so you can again get back the liquid water. Okay, so what happens in the process of evaporation, that is water in its liquid state changes into gaseous state. Okay, so here you can see, so in these clothes, these are wet clothes. Okay, so evaporation of water, an example of evaporation water is drying of clothes. Okay, so here what you do, generally the wet clothes, after washing the clothes, you let them dry outside where sunlight can fall on those. Okay, so what happens during this, so from this wet clothes, the water it leaves the clothes and it converts into water vapor. Okay, so if this vapor you can condense them, it can again change to liquid water. Okay, so this process is also an example of physical change. So what is evaporation, how does it occur? So these all you do not need in your this class 7. Okay, in this class you do not need how evaporation occurs, what is evaporation. So you'll be getting them in details, getting about the process of evaporation in details on your higher classes. Okay, again the magnetization of steel bar is also a example of physical change. Okay, so these are the example of some physical changes, and 2-3 more examples we have already discussed. Okay, so this is all about the physical change portion of your 6th chapter. Okay, from the next class we will be looking at the chemical changes, and we will be looking more on the importance of chemical change. Okay, so why chemical change is important, what are the properties of chemical change, and we'll be looking at some examples of chemical change as well. Okay, so this is all for today's class. Okay, so thank you.